Very good morning, dear students. Welcome back to Network Analysis video lecture series. In this video lecture, we are going to learn about magnetically coupled circuits. The content of this video lecture is, first of all, we'll understand and go through self-inductance, then mutual inductance. Then after we'll go for coupling coefficient, which is denoted by K, and then we'll go for dot convention in details of dot convention. To understand the basic concept of self-inductance and mutual inductance, it is actually very important to understand the basic concept of self-inductance and mutual inductance. In our previous semester, that is in semester 1 or semester 2, we have studied basic electrical engineering and we must have encountered this concept. The concept self-inductance and this mutual inductance. What is meant by inductance and what is self and what is mutual? The word self indicates something which is within the system in reference, and mutual means with the inspiration, something in neighborhood. Okay. The second point is to understand the concept of coupling coefficient and dot determination or dot convention. Dot is a word that means dot convention. But what is the real meaning of having dot convention or the need of determination of dot in circuit analysis? We'll understand and go in all the theoretical as well as numerical point of aspect of all these topics. Self and mutual inductance. Self and mutual inductance. When two loops with or without contacts, with or without contacts between them affect each other, mark the word affect each other through the magnetic field generated by one of them, it's called magnetically coupled. For example, your transformer. The example is your transformer. Why transformer? The primary section and the secondary section of transformer is electrically isolated. It is not connected electrically, but they are connected magnetically. An electric device designed on the basis of the concept of magnetic coupling. This is from transformer. It used magnetically coupled coils to transfer energy from one circuit to another circuit. Which is that circuit? The circuit primary to secondary. I am drawing this in short. This is number of turns N1, this is number of turns N2. This shows your core. This is supply volt. This is our induced EMF E1. This is our induced EMF E2. This is your output voltage, the resultant voltage, and this is your I0, no load current. Let us understand what is the meaning of self-inductance. What is the meaning of self-inductance? This is our topic. What is the meaning of self-inductance? Point number 1. It's called self-inductance because it relates the voltage induced in a coil by a time varying current in the same coil. By a time varying current, mark this word. This is time varying current. Time varying current. This is very important. In the same coil. Consider a single circuit having inductor. This is a single circuit having inductor. This one. With n number of turns. The number of turns here is your n number of turns. When current I flows, when current I is flowing, which is time varying current, through the coil, a magnetic flux phi is produced around it. In very simple, if I, which is a variable of time, flows through an inductor, we have flux around this inductor denoted by phi, which is also time variable in nature. We know this according to the Faraday's laws of electromagnetic induction. I have written here according to Faraday's laws of electromagnetic induction, or simply you can say Faraday's law. The voltage V induced in the coil or circuit is proportional to n number of turns and rate of change of magnetic flux. This is the statement, and this is a mathematical statement. This is in words and this is in an actual maths formula. V is equal to n d phi by dt. What is this? D phi by dt, the rate of change of flux with respect to time. Quality question number 1. But a change in the flux is caused by a change in current. We know this change in flux is brought to you by change in due to change in current. Therefore, this can be also written as d phi by dt is equal to d phi by di and di by dt. D phi by di and di by dt. Quality question number 2. Why I am writing this? It will be very much clear in subsequent slides. put equation number 2 into 1, that else V is equal to N d phi by dt, d phi by di into di by dt, or V is equal to, what is this whole thing, N d phi by di. This is your L. L is your number of turns into rate of change of flux with respect to current. Okay, inductor is your number of turns into d phi by di. This is your inductor and this is your IT, time variable current, and this is your setup of flux because of this IT. Whenever IT is changing, this phi is also changing, and this phenomena brings about your L. It is L is your N into d phi by di. From equation number 3, this is your equation number 3. From equation number 3 and equation number 4, the self-inductance L is defined as what I am given here. L is equal to N d phi by di, which is in Henry. The unit of inductance is in Henry. H, capital H. Now let us move towards the understanding of mutual inductance. In previous slide there was only one circuit diagram, there was only one inductor in the case, but now in mutual inductance, let us bring another inductor or another circuit in the existing system. That is, you are having one inductor, one circuit. Now bring another one in the neighborhood. When two inductors or coils, are in close proximity means in neighborhood, to each other, magnetic flux caused by current in one coil, see this very carefully, magnetic flux caused by current in one coil links with the other coil, therefore producing the induced voltage. It means what? The effect going on in one circuit causes to create effect in another one. Okay, that is why it is called mutual. Mutual inductance is the ability of one inductor to induce a voltage across a neighboring inductor. Let us understand via this circuit diagram. This is your current source given. Direction is upward like this. This is your I1T. This is your inductor. And this is the setting up of flux. This is flux created by one and coming to its own inductor L1. A part of this flux is also associated or cutting or relating the neighboring inductor L2. This is in proximity. Proximity means in neighborhood, or this L2 is in proximity of this L1, and the current which is flowing in circuit number 1. See this is a current I1 which is flowing in the circuit number 1 and which is generating this flux phi is going to induce EMF in this circuit. This effect on this circuit is actually your mutual effect, and the inductance which is caused by this process is called your mutual inductance. Hence, mutual inductance is the ability of one inductor to induce a voltage across a neighboring inductor. See this. Consider the following two cases. We are going to consider two cases to understand all this concept in deep. Case number 1, two coil with self-inductance L1, and L2, which are in close proximity, close neighborhood with each other. This is a figure number 2 in this subsequent topic. Coil 1, this is coil 1, has number of turns N1, and coil 2 have number of turns N2. This is coil number 2, number of turns N2. This is current I1T flowing in this circuit of N1 turns of self-inductance L1. Okay, and the flux produced in this L1 because of flowing of this IT through this L1 a part of this flux is associated with the neighboring inductor. See this, with the neighboring inductor. Whenever there is a conductor, this is a conductor. An inductor is nothing but a conductor in a special case. In wound case, this is a conductor of n is equal to 1. This is a conductor with n is equal to 10 or something, so on, with n number of turns. So it is your inductor. It becomes inductance, self-inductance. Now, if the flux produced here catches some portion of this inductor, there is mutual effect on this coil. There is induced EMF. See this? The magnetic flux phi1 from coil 1 has two components. Phi11 that links only coil 1 and phi12 links both coil. See this? This is your phi1 which links with itself. This is both. A part of this flux is linking this. A part of this flux is linking this. Part of this flux is linking inductor number 2. This is your inductor number 2. This was your inductor number 1. This is having number of turns N1 and this is having number of turns N2. So here I have written for you magnetic flux phi 1, which is generated by inductor 1, coil 1, has two components. The component is self component and the both component. Phi 11 component, that is phi 11 links to itself only, and phi 12 links both coils. Hence phi 1 is actually phi 12 plus phi 1, phi 11 plus phi 12. Phi 1 is actually equal to phi 11 plus phi 12. Phi 11 is the portion of flux generated which links to itself only. This is your self and this is your both, or can say mutual. Therefore, thus voltage induces in coil 1. Voltage induces in coil 1 because of the self inductance, that is V1 is equal to N1 into d phi 11 by di1 into di1 by dt. So this whole term N1 into d phi 11 upon di1 is your L1. L1 is equal to N1 into d phi 11 upon, with respect to di1 is your L1. So replace this whole thing with this L1. So lastly V1 is coming L1 into di1 by dt. Correct equation number 1. Thus voltage induces in coil 2. Voltage induces in coil 2 is given by V2 is equal to, what is the number of turns of coil 2 is N2. N2 will be equal to V2 is equal to N2 into d phi 12 by di1 into di1 by dt, and this N2 into d phi 12 by di1 is your M21. The subscript 21 in M21 means that the mutual inductance on coil 2 due to coil 1. M21 means inductance on mutual inductance on 2 because of coil number 1. Because of coil number 1. Let us go towards case number 2, which is same circuit but let current I2 flow in coil 2. Circuit is same but coil number 2 has been energized or current I2 has been flowed into the circuit as shown. See this, I2 is flowing and this I2 is crossing this inductor and there is production of flux. This flux will also have two components. One will be self-linking and another will be linking to the inductor placed in its proximity or in neighborhood और इसके पड़ोस में जो भी इंडक्टर होगा उसके साथ इसका एसोसिएशन होगा. The magnetic flux phi 2 from coil 2 has two components, as I had just discussed this, that it will be phi 2 2 links only coil 2, generates from 2 and links to 2, that is why it is phi 2 2. If it is generated by 1 and links to 1, therefore it is phi 1 1. If it is generated by 1 and links to 2, it will be phi 1 2. Hence, phi 2 is equal to phi 2 1 plus phi 2 2. Therefore, voltage induced in coil number 2 will be equal to V2 is equal to N2 into d phi 2 2 by di2 into di2 by dt. This is our self inductance of coil number 2 L2. So replace it with L2 into di2 by dt. So V2 is equal to L2 into di2 by dt. The self inductance, the voltage because of self inductance of coil number 2. And what is the value of current flowing in coil number 2? Value of current flowing in coil number 2 is your I2. See this. Now voltage induced in coil 1, V1 is equal to N1 into d phi 2 1 by di2 or di2 by dt in multiplication. This is your M12. Replace this thing with M12 and this is your di2 by dt. The subscript 1 to a mutual coefficient M12 means that the mutual inductance on coil 1 is due to coil 2. Since the two circuits and two currents are the same, therefore M21 will be equal to M12 is equal to the common nomenclature M. Mutual inductance M is measured in henries. Whether it is mutual or self, if it is inductance, the unit will be henries. Now, coupling coefficient K. It is a measure of the magnetic coupling between any two coils. The range is like this. The range of K is in between greater than equal to 0 and lesser than equal to 1. It means what? The minimum value will be 0 and maximum value will be equal to 1. If K is equal to 0 means that coils are not coupled. If K is equal to 1 means the coils are perfectly coupled. If K is lesser than 0.5 means the coils are loosely coupled. If K is greater than 0.5 means the coils are tightly coupled. This is very important as far as your objective exam is concerned, whether it is your RGPB examination or any kind of competitive examinations like GATE examination or SSC examinations. This kind of questions are actually very frequent and you must expect in your question paper. This is all about in this video lecture. I'll be coming with more topics in subsequent video lectures. Till then, thank you so much for watching this video. Go through all the concept and make all the notes. Thank you so much.